Okay, let's unpack this. We're diving into some really interesting research today. It's looking at a topic, well, a supplement you might think you know.
Right. Creatine.
Exactly, creatine. But forget the gym for a minute. We're exploring its potential for brain health, brain function.
Yeah, it's fascinating stuff. We're mainly drawing from this big narrative review in sports medicine. It pulls together a lot of the current thinking.
It seems like a really solid source. It doesn't just list studies, it digs into what we actually know and maybe more importantly, what we don't.
Mm-hmm. Especially around things like, how age or sex might change the effects. Big questions there.
Definitely. So let's dive in. What is creatine fundamentally, and how does the source explain its role specifically for the brain?
Okay, so your body naturally makes it, right, from amino acid.
Right.
And you get it from food, too.
Mm.
Red meat, seafood, that sort of thing. And then there's supplements, of course. Creatine monohydrate is the one the review mentions as, like, the most common and effective for boosting tissue levels.
Okay, yeah, that's the muscle story most of us know. But the brain connection, that's the bit that feels new. What's happening up there?
Well, it's actually super critical for energy in the brain. Think of it like a quick energy reserve, a buffer.
An energy buffer.
Yeah, it helps keep ATP levels steady when the brain's working hard. And even though brain levels are lower than muscle, the brain uses a ton of energy, like 20% of your body's total.
Wow, 20%.
And the source even connects low brain creatine levels to certain neurodegenerative conditions, so it seems pretty important.
Okay, so it's this energy support. How does it get into the brain if you take a supplement or eat it? Is that easy?
Well, that's where it gets interesting and a bit complicated.
How so?
It mainly has to cross the blood-brain barrier, and it needs a specific transporter for that, called CT1. Brain cells can make their own creatine too, though.
Okay, a transporter, CT1, makes sense. But the source mentioned a problem with that.
It did. See, this CT1 transporter, it's not, like, super abundant at the blood-brain barrier. And maybe counterintuitively, taking creatine might actually cause your body to make less of that transporter.
Wait, taking it makes it harder for the brain to get it?
Potentially, yes. It might also reduce the brain's own production slightly. It's a key difference compared to how easily muscles soak it up.
Huh. That explains a lot.
Yeah. And it's why the review suggests you might need, pretty high doses. Maybe 20 grams a day for several weeks, just to get brain levels up noticeably.
20 grams? That's quite a bit more than typical muscle doses.
It is. And even then, the uptake is slow. It's limited. They even mention researchers are looking at other compounds, like guanidinoacetic acid or cyclocreatine, things that might sort of sneak past that CT1 transporter.
Fascinating. Okay, so getting it into the brain is step one, and it's tricky. But let's say you manage it. What does the research say about cognition, memory, focus, that kind of thing?
Well, the picture's still kind of fuzzy, but emerging. Animal studies are often the starting point, right? And rodent studies do suggest creatine can help with cognitive tasks, learning, memory, especially in older animals. Some mouse studies found it improved, like object recognition, spatial memory, and it was linked to genes involved in neuron growth and protection.
Okay, animal studies suggest potential, but what about us, humans?
Yeah, it's not always a direct translation. And actually, the animal data itself had some interesting wrinkles, potential sex differences.
Sex differences. How?
Well, one study found spatial learning improved in female mice with an Alzheimer's model after creatine, but not in the males. Another saw benefits in female rats with induced cognitive problems, but again, not the males.
Wow.
So it suggests maybe the underlying molecular stuff is different between sexes.
So right there in the animal models, there's this sex difference hint. Does that carry over to human studies on general cognition?
That's where it gets murky. Human studies are really mixed.
Mixed.
Some studies, particularly in older adults, using those higher doses like that 20 grams a day for a week, did find some memory improvement. But then other studies, maybe lower doses in younger adults, found basically no benefit.
So maybe it's the age, or the dose,
Right.
or how long they took it.
Exactly. The review points to all those things: age, dose, duration, even how they measured cognition, all likely factors. And here's a key point the review makes.
Yeah.
A major limitation in a lot of the human cognitive studies is that they just didn't look for sex differences, even though the animal data was waving that flag.
Huh.
Yeah.
So we're kind of flying blind on whether those animal sex differences actually matter for human cognition in these studies?
Pretty much, yeah. The data often isn't analyzed that way. However,
Okay.
The source does highlight one situation where creatine seems to be more consistently helpful for cognition,
And that is
when your brain is under metabolic stress.
metabolic stress. You mean like being really tired, sleep
It needs-
deprived?
It's exactly. Sleep deprivation, intense mental fatigue, even low oxygen like hypoxia. The examples in the review are pretty compelling.
Like what?
Like, creatine helped people make fewer errors on tests when oxygen was low. It boosted executive function when people were mentally worn out. It reduced that feeling of mental fatigue during, like, a tough math task.
Okay, that makes intuitive sense given the energy buffer idea.
Yeah, the thinking is it might help the brain use oxygen more efficiently under stress. There was also that study with rugby players.
Oh yeah, you mentioned athletes.
Right. It helped sleep-deprived rugby players with their skill execution and improved performance and mood in young adults after they've been awake for 24 hours straight.
So the big question then is why? Why does it seem to work better under stress?
The source suggests it's really about meeting that peak energy demand. When the brain's energy systems are pushed hard, creatine steps in as that buffer.
Makes sense.
But the review is careful to say, we still don't know if your age or sex affects how well it works in those stressful situations. More research needed, as always.
Right. Okay, let's shift from general thinking to something specific and serious. Traumatic brain injury, TBI.
Yeah, TBI concussion. It really messes with the brain's energy systems. And often, brain creatine levels drop after an injury.
So the idea is maybe boosting those levels could help. Protect the brain, help it recover.
That's the rationale, and it's pretty strong. Animal studies here look quite good.
How so?
Giving creatine before a simulated TBI seemed to reduce the amount of damage. Giving it after seemed to help with recovery, too.
What's it doing?
Well, the proposed mechanisms are things like protecting the mitochondria, the cell's powerhouses acting as that energy buffer, reducing oxidative stress, and limiting harmful calcium buildup. Lots of protective actions.
That sounds really promising. Has that translated to human studies?
There's one key study the review highlights. It was open label, meaning everyone knew who got what, but it involved children and adolescents who'd had a TBI.
Okay, and what happened?
They took creatine for 6 months, and the results reported were quite striking for that group.
Like what kind of results?
They saw reduced time in post-traumatic amnesia, shorter times needing breathing tubes, less time in the ICU. Also, improvements on measures of disability and recovery, things like self-care, talking, moving, social interaction, behavior.
Wow.
And even reductions in common symptoms like headaches, dizziness, fatigue, and problems with speech or understanding. Really quite broad effects reported in that study.
Those are significant improvements for young people recovering from TBI. That's huge.
It really is. But what's interesting, again, is that the study didn't analyze for sex differences.
Ah, that theme again.
Yeah, and it's relevant because some other research suggests females might have higher rates of TBI and sometimes worse outcomes. So understanding if creatine helps differently based on sex seems important, but we don't have that data from this study.
Definitely a gap. Okay, let's move to another tough area, neurodegenerative diseases. Alzheimer's, Parkinson's, conditions where treatments are really limited. Is creatine being looked at here?
Yes, absolutely. Because energy problems are a common feature in many of these diseases, and sometimes creatine levels are found to be lower. So researchers are exploring it for AD, PD, MS, ALS, muscular dystrophies.
Let's start with Alzheimer's. Seems like a logical place given the energy connection.
It does seem logical. But interestingly, the review says there haven't actually been human clinical trials yet, specifically for AD.
Really? None.
Apparently not reported yet. Animal studies in AD models have been mixed, sometimes even negative results. And again, those hints of sex-specific effects popped up in the animal models.
Okay, so AD is still very early days, maybe even uncertain. What about Parkinson's disease?
With Parkinson's, the early animal studies looked good. They suggested creatine might protect the dopamine neurons that die off in PD.
Promising start.
But the human trials, the random controlled ones, have been mostly disappointing, at least for slowing down the main motor symptoms.
Oh, that's too much.
Yeah. Although there were maybe some small hints of other benefits. One study combined creatine with CoQ10 and saw it seemed to help maintain cognitive function. Another noted some improvement in depressive symptoms, so maybe non-motor effects. Hard to say for sure.
Okay. Multiple sclerosis, MS.
People with MS do have changes in creatine metabolism, but the few human studies trying creatine supplementation haven't really shown benefits for muscle function or capacity.
Why not, do they think?
The source speculates maybe MS affects how well muscles can actually take up the creatine. It's just a hypothesis. And since MS affects women more often than men, understanding any sex differences here is, again, really important, but under-researched.
Seeing a pattern? ALS, Lou Gehrig's disease?
For ALS, animal studies show some promise improved motor function, survival in some mouse models. But human trials, again, mixed or largely negative results, especially in patients who were already in later stages.
Did they try different doses?
Some studies tried higher doses, but that caused significant stomach problems, GI distress, for quite a few patients. We don't know if starting way earlier in the disease might help. It's an open question.
Okay, how about muscular dystrophies? MD.
Now, here the story is a bit different. These diseases often involve low muscle creatine. Animal studies looked positive. And in humans, specifically in boys with Duchenne and Becker's MD, studies did show improvements.
Improvements in what?
In muscle strength, muscle function. And it seemed pretty well tolerated in that group.
So it worked for young boys with specific types of MD.
Exactly. But it didn't seem to help the adults with those conditions or people with other forms of muscular dystrophy. So the benefit looks quite specific disease type and maybe specific age range, more effective when younger.
Interesting specificity. Last one in this category. Charcot-Marie Tooth disease, CMT.
Right, that's a group of nerve disorders causing muscle weakness. 3 studies looked at creatine by itself and didn't really find a benefit. But one study combined creatine with resistance training, and that study found some changes in muscle fiber types and improvement in a functional test, getting up from a chair.
So maybe it needs exercise to work in CMT.
It hints at a possible interaction, yeah.
Okay.
Creatine plus exercise might be different than creatine alone in that condition. Definitely needs more research.
So looking across all these neurodegenerative conditions, it's a real mixed bag, isn't it? Promise in some animal models, but often not panning out consistently in humans. And effects seem really dependent on the specific disease, maybe age, maybe exercise.
That sums it up well. It's clearly not a simple fix, and the details of each disease really matter.
Let's switch gears one more time. Mood disorders, depression, anxiety, huge global issues, and current treatments have limitations. Is creatine even being considered here?
Yes, and this is a really intriguing area, actually. The review notes that creatine often gets overlooked in standard brain scans that measure metabolism. But newer research is linking brain creatine levels to mood.
How so?
Some studies found that lower creatine levels in certain parts of the frontal lobe seem to correlate with higher depression or anxiety scores.
So lower creatine, worse mood symptoms, potentially.
That's the association they found. And based on that, people are exploring if supplementing to increase brain creatine could help.
And is it showing promise?
Some studies are showing promise, yes, but the results vary. And it probably comes back to that issue we talked about, first actually getting enough creatine into the brain. Dose and duration seem really key.
Can you give examples?
Sure. One study used a high dose 20 grams a day for 4 weeks, and it did manage to increase total brain creatine in healthy people. Another used a lower dose, 5 grams a day, but for longer, 8 weeks. And they found it boosted the effect of an antidepressant drug in women with depression.
Okay, so maybe it helps antidepressants work better.
That's what that study suggested. But then another shorter trial, similar doses, didn't find the same benefit. So maybe the length of time you take it is crucial for mood effects. It takes time to build up those brain levels.
Right, that slow uptake. What about how it might work? Any ideas on the mechanism for mood?
The review throws out a few possibilities. Maybe creatine acts a bit like a neurotransmitter itself, or maybe it boosts levels of things like BDNF, which is good for neuron health, or maybe it affects how brain cells release ATP, which is a signaling molecule. It's still speculative.
And what about individual differences here? Age, sex?
Again, likely important. The source notes brain creatine levels tend to go up naturally as we age. Most studies haven't found big overall sex differences in brain creatine levels.
But there's always a but.
But one study did find slightly higher levels in one specific brain area, the left basal ganglia in males, which is interesting because that area is tied to dopamine, and dopamine is definitely relevant for mood.
So the takeaway on mood is low creatine in certain brain spots might be linked to depression or anxiety, and boosting it might help, but we're still figuring it out.
That's pretty much the state of play. Supplementation shows potential, but we really need a much better handle on the best way to use it, dose, duration, and how it actually works, and how things like your age or sex might change the outcome. The review really calls for clinical trials testing creatine by itself for mood disorders.
Right, to really isolate its effect. Okay, so let's try and pull all this together, summing up this whole deep dive.
I think the main point from the source is, yes, creatine supplementation can increase creatine levels in the brain. It's just harder and slower than in muscle. And this might be why we see some of these positive effects on brain function.
Yeah, it seems pretty helpful for thinking and memory, especially maybe for older adults, and definitely when the brain is stressed, like from lack of sleep or hard mental work.
And there's encouraging data for TBI recovery, at least in the young people studied, and for some specific aspects of muscular dystrophy, again, mainly in younger patients.
The mood disorder findings are really interesting too. Potential there, but clearly needs more solid research, especially studies looking just at creatine alone.
And throughout it all, the review hammers home the gaps. We need long-term studies, different dosing strategies, understanding how exercise fits in, and crucially, really digging into potential age and sex differences and how people respond. That came up again and again.
So you can really see, can't you? Creatine is famous for muscles, but its possible role in brain health, boosting thinking under pressure, helping TBI, maybe affecting mood, impacting some neurological conditions. It's a really active and, frankly, exciting area of research right now.
Absolutely. The science is definitely still evolving. We're figuring out the best ways to use it and who might get the most benefit.
Which really leaves us with a final thought, doesn't it? Given everything we've just gone through, the potential benefits, but also all these gaps, especially around individual differences like age and sex, how does this change your perspective on where brain health research might go next? And what role could compounds like creatine play in that future? Something to definitely mull over.